Welcome back to our series on different integration techniques. This time, let's talk about integration using U-substitution. And here are the two problems that we are going to solve in this video. Let's begin with the first one. Find the antiderivative of the quantity 3x squared plus 2x times e raised to x cubed plus x squared plus 1 dx. We can think of integration using U-substitution as the unwinding of the chain rule of derivative. So basically, if we have chain rule in differentiation, in anti-differentiation, we unwind that effect of chain rule by using this technique called the U-substitution. Let me demonstrate with an example. In our problem, we have here two factors. You have this first factor, and you have this other factor, and we would like to get the antiderivative. Now, from the given, it is clear that e raised to x cubed plus x squared plus 1 is a composite function. The outer function is e to this exponent, and the inner function is this exponent itself. So if the derivative of the inner function happens to be one of the factors here, that's exactly the right time to apply this U-substitution technique. In this case, in the U-substitution, we let x cubed plus x squared plus 1 be equal to u, and getting the derivative of u with respect to x, we have 3x squared plus 2x. d over dx is an operation to get the derivative of u with respect to x. But in the U-substitution, we are going to pretend that this differential du and this differential dx are the numerator and denominator of the fraction. And so we can solve du now by multiplying both sides by dx to get du equals 3x squared plus 2x times the differential dx. With this as our substitution now, let's proceed to solving this. Notice that our du here is 3x squared plus 2x dx. We have the factor 3x squared plus 2x, and we have this dx here corresponding to this dx. So what we are going to do is, using the commutative property of multiplication, let's rearrange the factors. So we arrive at the integral of e raised to x to the third plus x squared plus 1, and then times 3x squared plus 2x dx. Notice now that this part here is our du, and this factor is our e raised to the u, because u is x cubed plus x squared plus 1. Therefore, we can now rewrite this as the integral of e raised to u, and then this part is our du. But what is the antiderivative of e to the u du? The antiderivative of e to the u is itself plus a constant. So this is now equal to e to the u plus c. We now have here an antiderivative in terms of u. But since u is equal to x cubed plus x squared plus 1, we can now unsubstitute u. So this would become e, our u is x cubed plus x squared plus 1 plus c. This is now the antiderivative of our given function. So what appears to be like a very complicated function happens to be easier to integrate because of the U-substitution. So this is now our final answer. Here is now a clearer presentation of our answer. Now, how do we know if our answer is correct? Remember that differentiation and anti-differentiation are opposite operations. So one reverses the effect of the other. So that if we get the derivative of e raised to x cubed plus x squared plus 1, which was our answer in the previous slide, notice that e raised to x cubed plus x squared plus 1 is a composite function where our outside function is e raised to this exponent and our inner function is this exponent itself. So to get now the derivative of this, we apply what we call as the chain rule. We first get the derivative of the outside function, which happens to be the function itself. because we are dealing here with the derivative of the natural number e, times the derivative of the inner function is 3x squared plus 2x. Then we can rearrange these factors using the commutative property, and notice that this expression itself is the integrand of the problem that we were solving at the start. So it just shows that the derivative of this is equal to this function. Conversely, the antiderivative of this function is this function, which was our answer that we arrived at. So it's verified that our final answer here is this function. Let's go to our problem number 2. So for our problem number 2, find the antiderivative of x squared times the square root of x cubed plus 4 dx. Again, this looks like a complicated function to integrate because of the presence of the radical sign. But using the U-substitution, we first let u be equal to one of these functions. We will let x cubed plus 4 be our u, because it happens that if we get the derivative of u with respect to x, we have this expression 3x squared, which is almost similar to one of the factors in the integrand. Again, we pretend that du over dx is a fraction instead of just an operation, so we multiply both sides by the differential dx to arrive at du equals 3x squared dx. Now we have a minor problem here because what we have in the integrand is x squared. What we have in this expression is 3x squared. The dx is here, so there's no problem with the dx part. But since 3 is a constant, it's not a problem. All we have to do is divide both sides by 3 in order to get du over 3 equals x squared dx. And so this x squared dx is equal to du over 3. So with this as our substitutions, let's now solve our problem. First, using commutative property of multiplication, let's rearrange the factors. That is, in order for x dx to be obviously one of the factors. And we know that x squared dx is equal to du over 3. So that means this part here is du over 3, and this x cubed plus 4 is our u. So in effect, this is just the same as the antiderivative of the square root of u du over 3. Now we can pull out 1 over 3 outside the integral symbol, and so we have 1/3 times the antiderivative of the square root of u du. Next, let's rewrite the square root of du as u raised to 1/2, and using now the power rule, we can find the indefinite integral here as the constant. We add 1 to the exponent, so this becomes u raised to 1/2 plus 1, which is 3/2, over the same exponent 3/2 plus a certain constant. Then we have here complex fraction, which we can simplify by just multiplying by the reciprocal of the denominator. So instead of dividing by 3/2, we multiply by 2 over 3, and 2 over 3 times 1/3 is 2 over 9. We copy u raised to 3/2 plus c. And then we now unsubstitute the value of u. U is substituted as x cubed plus 4. So let's unwind that substitution now. This now becomes 2 over 9 instead of u. We have this value, x cubed plus 4, then copy all the rest. And so this is now our final answer. Or if you want to write this in radical symbol, this is equal to 2 over 9 times the square root of x cubed plus 4 raised to the third plus c. And so this is now our final answer. Not all problems can be solved using integration by U-substitution. This only applies when you have composite function and the derivative of one of the functions happens to be equal or almost equal to one of the factors, such that by manipulating the other factor a little bit, we can fit the form into the reverse of the chain rule of differentiation. Since differentiation and anti-differentiation are inverse operations, then we'll be able to find the antiderivative by knowing what is the derivative. So thank you very much, and we hope to see you again in our next video.